Aiming Primary School.
My name is Kotashi, 8 apply to Otto from Aiming Primary School.
This lesson is Calculus, Chapter 6, Definite Integral. Do you still remember for indefinite integral and definite integral?
Yeah.
Indefinite integral. These methods, we can use it in definite integral, right?
Yep.
Well, for these indefinite integral, when you use these methods in definite integral, you have to be aware of the boundary.
Yeah.
Because for that boundary, there shouldn't be any singularities, right?
Yeah.
Okay, and remember for this definite integration, we have a lot of special methods, techniques, right? Like for example, what do you remember that we have? Like for example, from the single integration, change it to iterator integration, then change it to double integration, then change it back to iterator integration, and then change it back into single integration. And you get the answer. Amazing, right?
Yes.
And we also have the reduction. Am I right?
Yep.
Okay, so right now here we can have another of this method, okay?
Yeah.
So remember for this method, well, first we'll have to prove that.
Prove that
These two are equal.
Yeah.
Okay, so you realize that it might seem weird that sine become cosine. It looks weird, right?
Yeah.
But is it true?
Yep.
Okay then, can you prove it? And remember for this is the integrate from 0 to half pi sine to the power of 5x over sine x plus cosine x dx. This is equal to integrate from 0 to half pi cosine to the power of 5x over sine x plus cosine x dx. Okay, so first we want to let, right?
Yeah.
Okay, so that is your u, right? So it's integrate from half pi to 0, right?
Yeah.
So that the dx okay, and then your ending bracket. So let me just show you why we have like this, okay? So wait first.
Because I write the first.
Okay, you write that first, later I write, okay?
Okay.
Where is your dx? Okay, so for this part, what we'll have is, do you remember something like this?
Yeah.
Did you know that is actually true? That's why you need to put a half pi minus. So that from sine will change into cosine. Okay?
Okay.
So you can sub that in right now. That will be all. I think you're missing two things. Yes, that's one thing. And if it's a u, dx at first is a positive, negative. Next. So for this part, when you just look at one of the sign, it will become the cosine. So find out this. Yes. So this can actually just change it to a cosine. Well, this change it to a sine.
We don't get the variable, right? It could be u, x, y, whatever.
Yeah. And remember, for this negative, you can actually change these two places, right?
Yep.
So you just change it to x. So now follow this sine x, right?
Yeah.
So here's the sine and here's the cosine. So I think you're still missing a thing. So like this, it will be complete. So for this, what did you realize?
So
we use
for
the
that,
sine change to
cosine. First,
actually here first is substitution, right?
yes, after we use substitution, then from sine change it into cosine.
Then just use a negative, change the two positions, and then variable doesn't matter because at last we'll still sub it in, right?
Yeah, and we change these two places because it's a plus, so it don't matter.
So right now I clear off this. I can erase it.
Of course.
Okay. Okay, so right now I would find what is this. So for this part, you know that these two are equal, right?
Yep.
So can we add those two together? If we want to add them together, you will need a half. Am I right?
Yeah.
So it will become like this. Am I right?
Yeah.
Then after that, can we just cancel out this denominator? Because here plus perfect, we can take out one of them, right?
Yeah.
So for this, what it will become?
It will become a minus. So it will be to the power of 3 now.
So for this, then we have. Okay, so I'll write this whole thing down there, okay?
Okay.
So first, of course, is this to the power of 4. Then, here to the power of 3, am I right?
Yeah.
Then it's a cosine, am I right?
Yeah.
Is it right like this?
Okay. And why your over so curvy?
Then these two just cancel.
Okay.
So the sine to the power of 4x, cosine to the power of 4x, can we put it as completing square?
Okie
But what's missing? What will we need to minus?
we will need to. So we will need to minus.
You know what's this?
This part, and this part.
Okay, yes. But why minus this part?
We need to change it because there's an extra.
Because we need an extra of that, right?
Yeah.
I mean, we have an extra, not we need. So here, that's why we get this. So actually for these two parts, can we just straight away like factorize one thing?
Yeah.
So it's like this, right? So for this, we need to use the double angle formula for the sine.
Yes.
So are you sure it's like that?
Yeah.
Okay. What is this? You know what is that?
So this part will be.
Well, also. Okay, you write that first. And another thing is, why is this a 1?
1. Okay. Let me write it.
Okay, so it's because of that, right?
Yep.
So like this, and then what can we have?
And then. Okay, so now we'll have to.
So 1 can stay the same here first.
Yep. The minus sign.
Well, for this, what can we use again?
We can use the.
Double angle for cosine. Okay, so are you sure?
Yes.
So for this part, what we'll have? Okay, so actually this can separate, am I right?
Yeah.
So let's just separate that. When you separate, it'll become like this, am I right?
Correct.
So, first, this 1, which will have? The 1 will become an x, right?
1 will become an x, yes.
So, x times the x, it's actually the pi over 2 times the half. Then after that, 1 over 8. 1 over 8x, 1 over 8 times half pi, which becomes pi over 16, and then times the half. So therefore, this is what can we have? So at this part, it will be sine for x over 32, right?
Okay.
Sine for x. When you sub it in,
it's a 0.
then this part, which you can put the cosine in first, right?
Yeah.
So which will have the half sine square x.
Okay.
Then here is minus.
So it will be 1 over 2. You mean by 4?
Yes. And then this part, no. And then, for the 0, does this part have?
No.
This part?
No. No. This pi and this pi. No.
So what we'll get is 7 pi minus 8 over 32. So it's like that.
Correct.
So this is for our second part.
Which is solving it.
Okay, so when you get this answer, that means the cosine is also this answer. Right?
Yep.
Yep. Okay, so are you clear of all of these?
Yes.
Okay, and for all of these, you realize that we can use quite a lot of trigonometry, right?
Or identity.
Okay.
But in this case,
Or formulas.
In this case, we didn't use the trigonal identities, except for one. Thus.
Okay, so for this lesson, did you learn something?
Of course, something.
Okay, so for this, what did you learn from this?
So,
What did you realize? Say first, what did you realize?
from one of this may look that it can not from sine become cosine, but actually it could.
Using the substitution, right?
Yes.
And then how about for the second part?
For the second part,
Well, you just combine these two, half.
yes.
Like that.
Yep.
Okay, so for this lesson, what else do you want to say before we end this?
Don't forget to click this subscribe button if you like our video.
Okay, so can we end our lesson here?
Okay.
See you in the next lesson.
Okay.
Thank you for your watching.